In September 2023, a megatsunami in Greenland triggered seismic waves worldwide caused by a landslide in Dixien Fjord. The event generated two seismic signals, a high-energy signal from the landslide and a long-lasting VLP signal from a siege in the fjord. The findings offer new insights into the risks posed by these types of landslides in Greenland. So let's get into it. In September 2023, a massive tsunami in a remote region of eastern Greenland triggered seismic waves that captured the attention of researchers worldwide. The event created a week-long oscillation wave, and it was in Dixien Fjord, according to a new report in the seismic record, which we will link you below. Angela Carrillo-Ponce of GFC, German Research Center for Geoscience, and her colleagues identified two distinct signals in the seismic data from the event. One high-energy signal caused by the massive rock slide that generated the tsunami, and another very long period VLP signal that lasted over a week. Their analysis of the VLP signal, which was detected as far as 500 kilometers away, that is 3,100 miles, suggests that the landslide and resulting tsunami created a siege, or standing wave that oscillates in a body of water. In this case, the siege was churning for days between the shores of Dixien Fjord. The fact that the signal of a rock slide triggered sloshing wave in a remote area of Greenland can be observed worldwide and for over a week is exciting. And as seismologists, this signal was what mostly caught our attention, said Carrillo-Ponce. The analysis of the seismic signal can give us some answers regarding the processes involved, and may even lead to improved monitoring of similar events in the future. If we had not studied this event seismically, then we would not have known about the siege produced by the fjord system, she added. The findings will help researchers as they study the impacts of landslides in Greenland and similar regions around the world where warming and the loss of permafrost are making rocky slopes and glaciers increasingly unstable. In western Greenland, recent tsunamis have had devastating consequences, such as the 2017 Karat Fjord event, where an avalanche caused a tsunami that flooded the village of Nugasasik and killed 4 people. Megatsunamis over 100 meters or 330 feet high off the east coast of Greenland have also reached Europe. The September 16, 2023 megatsunami took place in Dixien Fjord, in a remote part of eastern Greenland, and was first noted on social media posts and in a report of waves hitting a military installation on Ella Island. Carrillo-Ponce and colleagues studied both seismic signals and satellite imagery from the area to precisely locate and reconstruct the series of events. Their analysis of an initial high-energy seismic signal combined with satellite images of a missing rock patch along a cliff along Dixien Fjord allowed them to trace the direction of the landslide as it picked up glacier ice and became mixed with rock ice avalanches before it reached the water. The resulting megatsunami run-up was more than 200 meters, or 650 feet, near the water entry point, and an average of 60 meters, or 200 feet, along a 10-kilometer stretch of the fjord. So here you can see on the map that landslide point, the chunk of rock missing, the direction of movement, and then the water would be sloshing back and forth in this little slot for the entire length of the fjord. While we were able to obtain information on the direction and magnitude of the force exerted by the landslide, We do not have the data to investigate the original causes of the landslide, Carrillo-Ponce said. The strength, radiation pattern, and duration of the latter seismic VLP signal best fit a scenario where the tsunami created a long-lasting siege in the fjord, researchers found. Now, a siege is when water, if this is the profile of the fjord, sloshes back and forth due to physics. And in this case, it lasted for a week. As you can see here in the ebbs and flows of the spikes in the VLP data. VLP signals have been observed previously in Greenland, but they are usually associated with iceberg collapse due to glacial earthquakes. In our case, we observed a VLP signal too, but the main difference is the long duration, Carrillo-Ponce explained. It's quite impressive to see that we could use good quality data from stations located as far away as Germany, Alaska, and North America, and that those records were strong enough for at least 1 week. The researchers say their approach might prove useful in studying similar past events and their possible link to the climate and environmental changes. We have compared our results with remote sensing data to validate our solutions, and our study shows that the force produced by the signals is well resolved, according to Carrillo-Ponce. Therefore, it becomes a useful analysis as seismic signals contain information on the type of source generating the signal and how the energy is radiated. Conclusions. On the 16th of September, 2023, a mass wasting event occurred at 12:35 UTC in East Greenland, where a rock mass on an area of 1.6 times 10 to the 5th meters squared and a height of 50 to 100 meters detached and impacted initially to the west, falling around 300 to 400 meters in a slope of 30 to 40 degrees. The initial west direction is well resolved with an SF model, which retrieves F equal to 530 GN. After the first impact, the rock slide material is redirected to the north and interacts with the glacier until it enters the Dixon Fjord, where it triggers a megatsunami with a peak run-up height locally exceeding 200 meters. After the LP signal produced by the landslide, a VLP monochromatic oscillation was generated and lasted at least 1 week. This long signal and its amplitude decay are well explained with a damped oscillator model that contains a linear and quadratic contribution in which the major role is played by the quadratic term, but a combination of both factors is needed to fit the amplitude decay. A fundamental mode standing wave with an average initial amplitude of 2.6 meters in the narrow direction of a 2 by 20 kilometer fjord segment explains the dominant frequency of the VLP oscillations and gives a plausible mechanism for the strength, radiation pattern, and long duration of the seismic VLP signal. In layman's terms, this dramatic spike followed by these oscillations show what occurred in this fjord. Because of its width and its length being constant here, when it was initiated, it caused a standing oscillation along the length of the fjord. And that is the conclusions based on this graph. I hope you enjoyed the presentation. Please leave a thumb up. All the links to everything we discussed will be below.